นี่ Yuk, nih. Kan udah mau colokin ke ini mudah-mudahan.
When a well is produced, the fluid comes to the surface as an emulsion of oil, water, gas, and solids. Emulsions in the oil and gas industry are either classified as water in oil or oil in water, depending on the ratio of the volumes of liquids. Gas brought to the surface is usually wet gas, composed of dry natural gas like methane, mixed with liquid natural gases like ethane and butane. All of these components are separated. Natural gases like
Ini gampang banget ya anaknya. Tapi kita harus pakai apa ya? Beberapa orang memaafkan lagi.
ethane and butane, and natural gas like methane, mixed with liquid natural gases like ethane and butane. All of these components are separated using multiple principles of separation to achieve the desired end products that are considered valuable. In this video, we'll explain 6 separation principles used for emulsion in the oil and gas industry. The first principle we'll discuss is heat. When separating liquids from each other, heating to certain temperatures enhances separation. When the temperature of an oil and water emulsion is increased, the viscosity of oil is decreased. This lower viscosity allows the gas and water molecules to be more easily released. Heating oil emulsions also increases density between oil and water. A heater treater is an example of a vessel which uses the principle of temperature change to aid in separation. For more on how a heater treater works, check out our Training Level 1 series. Our second principle is gravity separation. The elements in the well stream, such as oil and water, have different gravities. The density differences allow water to separate by gravity. With enough time in a non-turbulent state, the differing specific gravities will naturally separate. To picture this, think of the emulsion as Italian salad dressing. If you let the dressing set, the ingredients will separate according to their different specific gravities. The olive oil will float on top because it is lighter than the vinegar, and the solids and other ingredients will fall to the bottom because they are the heaviest. The next principle directly relates to gravity separation and is called retention time. Retention time is the amount of time the fluid stays
During this overview of the oil and gas industry, we will look at the early days, explain the three sectors of the industry and some of the differences. There will be videos covering common topics often discussed today, and we'll touch on the different geological formations that upstream producers drill and produce. Our focus will then shift to different types of wells producers use to bring their resources to the focus will then geological formations that upstream producers drill and produce. Our focus will then shift to different types of wells producers use to bring their resources to the surface. Then close Separators in one form or another are the most used vessel in the energy industry. Scrubbers, knockouts, treaters, drip pots, and gun barrels are all forms of separators. In this chapter, we will introduce you to two types, horizontal and vertical emulsion separators. Separation happens in many ways and for a variety of reasons. Think about why you separate what you recycle from the trash. It's helping a process that's going to take place later. It boils down to the fact that there are advantages to separating things. The same is true in the energy industry. Resources come to the surface in many forms and combinations. Separation adds value to the resources. Sometimes we separate components for safety reasons. Nature helps us in the separation process. Often, the differences in specific gravity of a resource are all that is needed to facilitate separation, but they need enough time and a steady state to do so. Retention time is a big factor in the separation process. Retention is the amount of time that a fluid stays in the separator. With enough retention, the different specific gravities will settle or separate from the emulsion. You can see in this example, over time the fluid separate as they move from the inlet side to the outlet. Some other outside influences that are needed to achieve separation are mechanical devices such as diverter plates. That are needed to achieve separation are mechanical devices such as diverter plates, wave breakers, mist extractors, and weirs. All three sectors of the energy industry incorporate separation in their processes. Initial separation occurs in the upstream sector. As the resources are moved through the midstream sector and the conditions that they are exposed to change, there is a need to further separate the product. Separation is needed in the downstream sector to achieve the final product before it goes to the consumer. This short list shows the most common places you will find Kimray products controlling the separation process. Separation takes place when the makeup of a well stream is not meeting the customer's requirement. Separation takes place when the makeup of a well stream is not meeting the customer's requirements. There are guidelines to help producers decide the extent of separation needed. We will discuss these guidelines in more detail in Level 2 separation. Here are a few pictures of common styles of separators. The customer's needs determine what type of vessel that the equipment manufacturers make. The size, working pressure, separation capabilities, accessibility to the internals, and whether it's horizontal or vertical could all be factors that determine how a separator gets built. Phases will be discussed multiple times in these chapters. Two-phase simply means that we are separating gas from liquids. Three-phase means that we go a step further and separate gas from oil and oil from water. It all goes back to the customer's requirements. Separators can be high or low pressure. Anything under 500 psi is considered low pressure, and anything above 500 psi is considered high pressure. Kimray provides different options for the controls on these vessels for both high pressure and low pressure. There are times that you have to look closely to see the differences between high and low pressure vessels. One confusing factor is that high pressure controls are sometimes needed on low pressure vessels in order to have proper control. High pressure controls can work well on low pressure vessels. However, low pressure controls do not work well on high pressure vessels. We define mechanical controls as any device that uses levers and linkages to operate. Pneumatic controls use some form of gas to operate and control. These gases can be natural gas produced from the well or air supplied by an outside source like a compressor. There are other gases used in our industry for supply, but these are the most common. Here we see the different combinations of Kimray controls used in different applications. If the operating pressure is low enough, mechanical controls are a great choice. Some regulatory agencies tightly control fugitive gas emissions. Mechanical valves don't use gas to operate and therefore don't emit gas under normal operation. Enclosed buildings usually found in colder climates may not allow pneumatic controls to be used for safety reasons. The quantity and quality of gas is important when choosing pneumatic controls. The process may also dictate when pneumatics are required. For example, metering fluids usually requires pneumatic controls to maintain a level of accuracy because they can be opened and closed quickly. Please familiarize yourself with the basic connections of this vessel. Thank you for participating in this training. This chapter will introduce you to heater treaters. We will walk through the basics of separation, types of treaters, pneumatic and mechanical controls. A heater treater is a production vessel designed to heat production fluid. When production fluid is heated, the process of separation is accelerated. The use of heater treaters to separate crude oil is typically found in the upstream sector. The emulsion produced from a well is made up of three main elements: oil, gas, and water. The reason we separate these elements is to make them more valuable. The main goal is to make a natural resource more attractive to the buyer. Purchasers of crude oil don't want there to be any gas and water in their oil they are buying. That would hinder them from making the final product that consumers need. Why are both vertical and horizontal treaters made if they do the same job? Vertical treaters are a more cost-effective option than horizontal. Vertical treaters don't require as much pressure to operate as horizontal treaters do. Vertical treaters reduce the overall footprint of the equipment. On the other hand, a producer may specify a horizontal treater if they need to handle higher volumes of fluid. The burner tube in a horizontal treater has more surface area than volumes of fluid. The burner tube in a horizontal treater has more surface area that comes into contact with the emulsion, which allows a higher flow rate than vertical treaters. Notice the Kimray products in both pictures. The vertical treaters use treater valves on the oil and water dumps, while the horizontal treater uses mechanical dump valves. The other products shown are often used on both vertical and horizontal treaters: gas back pressure valves, thermostats, and burner valves. All treaters need to have some type of burner management system, or BMS, to control the heat. Keeping a constant temperature in the treater is very important to the separation process. You don't want things to get too hot, but if they're not hot enough, you won't get the separation you need. Whether the treater is vertical or horizontal, all heater treaters are considered three-phase separators. This means that all three phases of separation take place. Water falls to the bottom of the treater and is dumped downstream for recycling or disposal. Oil settles just above the water and is dumped downstream for storage or sales. Gas rises to the top of the vessel and is piped to a sales line, VRU, flare, or combustor. Heater treaters are often the last stage of separation before a resource gets stored or sold, so it is important that all three phases get separated. Operating pressure is the pressure a vessel is normally operated at. Working pressure is the maximum pressure each vessel is rated for. Most modern heater treaters operate at a pressure of up to 125 pounds. Kimray products used on those treaters have an operating pressure of at least 125 psi. A heater treater can be operated using pneumatic or mechanical controls. Pneumatic controls are used if the producer needs to meter fluids. Pneumatic controls can be snap action, which provides more accurate measurement in the metering process. Pneumatic controls offer more flexibility and sizing as well. Mechanical controls are still by far the most popular option. They have a lower operating cost and have minimal emissions when compared to pneumatics. You will need to know the basic flow and connections of a vertical treater when talking with the customer. The well inlet is where the well stream enters the treater. It may be coming directly from the wellhead or from another upstream vessel like a free water knockout, which has achieved some initial separation. The gas outlet is where the gas, which rises to the top of the vessel, is removed. It goes to one of two places: flare or combustion, or sales. The oil outlet is where the oil, which has settled to the middle of the vessel, is processed out for storage and sales. The water outlet on the right side is where the water, which has fallen to the bottom of the vessel, is dumped out for recycling or disposal. Please take the time to familiarize yourself to the different connections labeled on this picture and the functions of the Kimray products shown.
buset, Cok. Bisa lihat main. Oh, yang 3D itu gimana? Ya Allah, susah banget sih ngasih tahu ini tablet. Aduh. Sumpah bener-bener tablet nih. Ampun, tablet ampun. Ini bisa gambar TV lagi. Kenapa nggak bisa sih? Cuma muterin garis aja, nggak bisa garis. Ya Allah. Nih, lihat ya. Muterin garisnya putus-putus. Loh, tulisnya putus-putus. Ya Allah. Ya Allah. banget sih ini. Halo?
Kalau malu ikut ini nonton.
Nggak tahu.
Lah kan lu tim ses PA,
Iya,
terus gimana?
nggak tahu.
Ikut be,
Ya udah.
ayo, cewek.
Ya udah jemput lah.
Ada. Mau tuh.
spiral loh. Nah, bagus ya. Bisa coba.
kami datang, kami berjuang, kami maju untuk Adam.
Nanti aku
Dari jalan sayang. Aku cinta Cirebon, aku cinta FTTM, aku cinta ITB, aku cinta Indonesia, aku cinta bumi.
makin